clip, we will be discussing piecewise functions. While we answer this question together, you will be solving the similar problem on your own using the same technique. So given f of x is equal to the absolute of 2x plus 4, we are asked to find f of 0, f of negative 2, f of negative 5, and then to sketch its graph. Taking a closer look at our piecewise function here, we find that our function equals 2x plus 4 if our 2x plus 4 is greater than or equal to 0. However, if our 2x plus 4 is less than 0, then our function will equal negative 1 all times 2x plus 4. So let's begin by finding f of 0. This here means that we want to evaluate our f function when our x is equal to 0. However, we need to determine which function we're going to use, the 2x plus 4 or the negative 1 all times 2x plus 4. So to determine which function we are going to use, we need to substitute our x equals 0 into our restriction here. Once we do that, if we find that our answer is positive or equal to 0, satisfying this restriction, we will use this function here. Whereas if it is less than 0, satisfying this restriction, we will use this function. So to begin, we need to plug in our x equals 0 into 2x plus 4. So we will have 2 times 0 plus 4, which we find is equal to 4. Now, since 4 is greater than or equal to 0, it satisfies this condition here. So we will use the function 2x plus 4. Therefore, we want to use f of x is equal to 2x plus 4. Now we need to evaluate this function when x is equal to 0. So f of 0 is equal to 2 times 0 plus 4, which as we solved earlier, we found was equal to 4. I now want you to solve f of 0 for the function given in your question. You should have found that f of 0 is equal to 6. Now let's evaluate for f of negative 2. Once again, we need to substitute our x equals negative 2 into this 2x plus 4. So we have 2 times negative 2 plus 4. Negative 2 times 2 is negative 4 plus 4 will give us 0. So again, it satisfies this restriction here because we know that 0 is greater than or equal to 0. Since this restriction is satisfied, we are once again going to use the function 2x plus 4. So therefore, we are using f of x is equal to 2x plus 4. Now we need to evaluate this when x is equal to negative 2. So f of negative 2 is equal to 2 times negative 2 plus 4, which as we found earlier, f of negative 2 is equal to 0. I now want you to solve for f of negative 2 in the question you are given. Your answer should have been f of negative 2. Going back to our question, we now need to find f of negative 5. So now we're evaluating our f function when our x is equal to negative 5. Once again, we need to substitute this into our 2x plus 4. So 2 times negative 5 plus 4. 2 times negative 5 will give us negative 10 plus 4 is equal to negative 6. So now, our answer is no longer greater than or equal to 0 it actually satisfies this condition when it is less than 0, since our answer is -6. So the function we were going to use to evaluate f of -5 is 2x plus 4 all times -1. So here we have that -6 is less than 0. So therefore, the function we are going to use is f of x is equal to negative, and then in brackets we have 2x plus 4. We are now going to evaluate this when x is equal to -5. So we will have f of -5 is equal to negative, and now I'm going to use square brackets here because I'm going to write my x when I substitute the -5 in there with round brackets. So we'll have 2 times -5 plus 4. And we close this bracket here. And we're going to have the negative on the outside. We'll evaluate this here. 2 times -5 will give us -10 plus 4. Okay, now we need to do bed math, so we need to figure out what's inside our brackets here. We do that by simplifying. -10 plus 4 will give us -6. And finally, -1 times -6 will give us +6. So f of -5 is equal to 6. I now want you to solve for f of -5 in your question. You should get that f of -5 is equal to 9. The last part of the question asks us to sketch the graph of the piecewise function. So to do this, we will start off by drawing our x and f of x axes. Because we're graphing the function of the absolute value of 2x plus 4, we know that our function will always be positive. Now, looking at what we evaluated here, when our x was equal to 0, we found the value of our function was 4. So when x was 0, which is here, the value of our function was 4. So we know this will be a point on our graph. I'll label it 0, 4. Over here we evaluated our f of -2, and we found it to be equal to 0. This means when x is equal to -2, our f of -2 was equal to 0. So x was -2, we found that our y was 0. So we have this point here, -2, and our y is 0. Lastly, we evaluated when when our x was equal to -5, our value of our function was 6. So we know that this is going to be a point somewhere here. I'm just going to estimate somewhere here. So now 2x plus 4 will give us a line with a positive slope. This determines that our slope is positive since the 2 is positive. Over here we will have a line where the slope is negative, because once this negative is distributed inside of the bracket, the number in front of the x will determine whether our slope is positive or negative. Since in this case we'll have -2, our slope of our line will be negative. So all we're going to do now is we're going to connect these two lines here. And over here we're going to have the positive slope. And over here, if we connect these 2 points, we know the slope of this line will be negative. So this is the graph of the function 2x plus 4, all in absolute value bars. I want you now to graph the piecewise function given to you in your question. Your graph should look similar to this.